In this problem, we would like to find the minimum of a given specific type in this way. To solve this problem, it seems like we need first to extract the items of the specific type, then finding the minimum among them. To do that, I am using here a list comprehension because it's the most Pythonic way to do this problem. So I'm iterating on the list and then I'm checking if the type of the item is the target type. So we pass here the type of some object and I'm checking against it if it's same type or not. If it happened, then we have a new list. Now the list could be empty, so do not run a minimum over it. Check first if the list is empty, return none, otherwise return the minimum of this list. That's all. In the second assignment, we would like to check if a list is a sublist from a list or not. To be sublist, you need to be order and consecutive. So to do that, I'm checking here first if the list is empty as a special case, which is definitely true. I'm also checking if the list is bigger than the main list, then this is definitely a false case. Otherwise, I'm just trying to extract every sublist and check it. So move with index and every time extract the last starting from this index up to the length. Let's say the sequence, the sublist here is 4 items. So in the beginning we extract from 0 to 4, then from 1 to 5, from 2 to 6, and so on. And every time we check against the target list here. For efficiency, I am here adding that you shouldn't try windows more than necessary. For example, it doesn't make sense that your list check would be, for example, 5 characters and you are at the last character here and trying to match with that. I'm just matching whenever I can match more and more. For example, if the main list is 6 items and the list check is just 3 items, then it makes sense to check at position 0, position 1, position 2, and so on. But it doesn't make sense to check at position 5. Notice that even without this condition, the code is still working well. It's just a little more efficient. In a language like C++, for example, this code will fail because you will access index beyond the sequence. But the slicing here, the slicing will slice anyway whatever valid subsequence up to the end of the sequence. This is how we can do it. Observe that this code is a bit inefficient. The reason is slice isn't memory efficient. Slice is going to make a copy of the main list and assign the items from them. So it's like actually taking a new memory for the items. Another way is, instead of having a slice like that, you can switch that with a for loop by yourself and compare element by element. This has the advantage of avoiding to create the extra memory here. So which one to go? This is a very important question. There are two things here. Sometimes when we try to make our approach more efficient, the code might be ugly or harder to read or longer or like error prone. There could be a lot of problems. The rule is, do you really need such an extra efficiency? Does it really matter? If not, then code clarity and code simplicity should be the priority. So in other words, if there are multiple ways to solve your problem, you have to think which one is more proper to your situation. It isn't like that, like there is one way always to solve the problem. This is typically happens. The same problem can be solved in many ways. Some of them might be the right choice and some of them might not be. If you are running on a mobile in a very memory limited environment, maybe just going with a very efficient solution is the way to go. But maybe in another case, let's say that we expect this list to be like maybe 200 elements and this list to be maximum like 500 elements. Probably this is very, very good enough. But if this list, for example, can be like 10 million numbers and this list check can be like maybe 500,000 numbers, then this is now a lot and this is risky. So you have to be careful and have to think and decide properly. That's all.